Okay, so we're going to be talking about how to graph systems of inequalities. We're actually going to graph each of these guys one at a time, talk about the shading, the test points, and all of that stuff. So if you're confused on how to just graph one linear inequality, two variable doodad like one of these guys would be, you can get the information that you're looking for out of this video as well. So here we go. We're looking at the first guy. I'll look at the first equation right there. Y is less than or equal to negative x plus 5. And I'm going to graph that using my graphing shortcuts. So I'm going to start at 5. So I'm going to go 1, 2, 3, 4, 5. And I got my y-intercept at 0, 5. And my slope, it's a negative x. So my slope is negative 1, which means I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. Oops, made an extra dot in there. Over 1. And what's important about this is as you're making your boundary lines is that you actually really extend them to the edges of whatever you're graphing with. That way you've got a solid line to work with so you can see how the shading is going to work across the entire graph. So this guy is less than or equal to, which means I'm going to have a solid line for my boundary. So I got my solid line in there. Okay, so there's my boundary point, just as so. That guy's been graphed. And then I'm going to graph my other boundary line. Let's use green for that one because green is such a neat color. Again, using my graphing shortcuts. I'm going to start at negative 1. The slope is 2/3 because this is a 2/3 x, which means I'm going to go up 2 over 1, 2, 3. Go up 2, 1, 2 over 1, 2, 3. Up 2 over 1, 2, 3. Here we go. Continues like that. I'm going to go by down 2 over 1, 2, 3. Put the point, down 2. And it continues along the line. And here we go. So this guy is not equal to, so it's going to be a dotted line. Wasn't a very good dotted line, but you get the idea. Arrows on the ends. Here we go. Arrow. That's a arrow that I would have made in 3rd grade. Maybe I'll make it a little bit better. I got all that stuff set. Now the question is where am I going to do my shading? So I'm going to use the test point 0, 0, since 0, 0 is not on either of the lines. So my test point is this point right here. I'm going to use it for both of them. That's my test point. Okay, 0, 0. And I'm going to test with the first guy. I'm going to put in 0 less than or equal to negative 0 plus 5. Continuing down the lines, here we go. That's 0 plus 5. And I get this guy right here. 5, or I should say 0 is less than or equal to 5. And that's true. 0 is definitely less than 5. So my test point gave me a true guy. So I'm going to shade over my test point because my test point worked. So I'm going to shade here, just like so. This is my shading. I don't want to go too crazy with my shading. I just want an idea of what's going on here because I'm going to be shading in another color in just a moment. So there we go. I shaded over my test point. Now using the next guy, I'm going to plug in 0, 0 again. It works for this guy too since the line did not go through 0, 0. So I got 0 greater than or equal to 2/3 times, that was supposed to be times 0. Excuse my terrible handwriting there. Multiply everything out. 0 is bigger than negative 1. Again, 0 is bigger than negative 1. This is a true statement. So now I'm going to shade above this line because that's where the test point is. It's above. I'm going to shade where my test point is. You're going to notice I'm about to shade right there. I'll do it again. I'll shade right through my test point. That's where it is. So then I'm concerned about, with a system of inequalities, where the solution region is. So I'm going to take my guy. I'm going to, we'll do it with smiley faces this time to make it a little different. My solution region is all the stuff on my graph that's all in here. This is my solution region. You see where it was green and blue with the crosshatch. 0, 0 worked on both of them. So I'm going to go over my test point. That guy's right there. And it's just smiley face town in here. Just craziness how many smiley faces I just made in there. All of those were made just for you. I'm just going to add some more just because they're so pretty. Okay, so that's that guy. That's all that we need to worry about. Next guy. Pretty straightforward. Again, we're going to graph our line. So I'm going to start by graphing this first guy. I'm going to start at 3. 1, 2, 3. Plot that guy. I got a 2/3 as my slope, so I'm going up 2 over 1, 2, 3. Up 2, 1, 2, 3. Same kind of thing. Go in the other direction. 2, 1, 2, 3. Yeah, down 2, 1, 2, 3. And this guy is a solid line this time, so I'm going to make my solid line, my very, very solid looking solid line. It's kind of squiggly there. That'll happen. And my next guy I'm going to make with a green is just 2/3 x. That's going to go through 0, 0, so watch out on this one. Going up 2, 1, 2, over 1, 2, 3. These lines have the same slope, and if lines have the same slope, hopefully you recall that that means that they are going to be parallel. And that's why this problem is a little bit different than some of the other ones. Again, it's equal to, so we're going to have a solid boundary line. Looks like that. So here we go. I'm going to test my top guy. I'm going to use the point 0, 0. I can with this one because the line doesn't go through it, which makes it kind of nice. Again, the test point that I'm using is 0, 0. So I'm going to put in 0 for both x and y plus 3. So that's that guy. Not too bad. Just keep going down the line. Do a little multiplication here. 0 plus 3. Notice I'm showing all of my steps here, and you should too, just because always show our work. Always show those steps. Even if they're things that, yeah, you can do them in your head, that's great. That takes an extra 3 seconds of your time just to write it down. Just do it. It makes it a lot easier in case you make a mistake. It's easy to make mistakes when you can't see what's going on. So 3 is bigger than 0. 0 is less than or equal to 3, however you want to look at that guy. It is actually eating the bigger one, so we call this guy true. This is a true statement, and that means that 0, 0 worked for the blue one, so I'm going to shade down with this guy, and shade down here through 0, 0, through my test point. My test point was right here. I'm shading through my test point and every other point that is on this side of the boundary, because it's either going to work on one side of the boundary or the other, and it worked for our test point. That means all of our solutions are on that side of the boundary. Now I'm going to use the green guy. Now, I can't use 0, 0 as a test point here because the line goes through it. So you can't test if one side or the other works when you're testing on the line. I always tend to use nice numbers like 2, 2 or 3, 3 or 1, 1 or something like that. In this case, I'm going to use 3, 3, and I'll show you why for my point. Just because when I multiply 2/3 by 3, it's going to come out to be a nice number. I always use like 1, 1, 2, 2, 3, 3, 0, 0, something like that. That way I won't get confused on what goes in for x and y. I'm just trying to be a little bit lazy, make it a little bit easier for myself, avoid mistakes whenever I can. So 2/3 of 3. If I broke 3 up into 3 equal pieces, well, it'll be 1, 1, and 1, and I'm going to take 2 of those, which means that I'm going to then have 2. So 3 is greater than or equal to 2. Again, this is a true statement. So I tested the point 3, 3. So that guy is at right here, 1, 2, 3, 1, 2, 3. That's that point right there. I tested it and it worked. That means that every guy above the green line here is going to work. And you can see where the blue and the green overlap. That is our solution region, or our solution area for the problem. So that's all there is to that guy. So to highlight it this time, we'll use the rainbow because that's pretty neat. The solution region's in this spot right here. Now we got this neat looking rainbow going on in there. So there's our solution region, and it continues. So there's that guy. Next one, last one that we're going to be looking at in this example video. We've got y is less than or equal to, hold the phone here, those bars mean absolute value. We haven't talked about any graphing shortcuts yet for absolute value, so I'm going to make an XY table in order to graph that guy. So I see absolute value, I'm going to instantly make a table because I don't want to mess any of this stuff up. Okay, so I'm going to grow from, let's say, -4, -3, -2, -1, 0, 1, 2, 3, 4. It should be a pretty decent table for most of the ones that we run across. Now, the absolute value of x, the absolute value means the distance from 0, or just simply make all the numbers positive. So I'm going to take my absolute value of -4, and I'll show you in this example. The absolute value of -4 plus 4 is going to be translated to, change it to a positive, and then add 4, so we get the number 8. And I know we kind of went way over on that guy, but that happens. So going forward from here, I know that -3 is going to become +3, and I'm going to add 4. -2 is going to become +2, and I'm going to add 4. Same thing here. 0 is going to become positive. These guys already are positive, so no big deal. When we graph these, whoops, that should be a number 2. When we graph these guys, there should be a particular shape that you're looking for. A graph of any absolute value function that you're going to see in this course is going to be one shape in particular, and that shape is the V. So 7, these add to be 6, 5, 4. This guy adds to be a 5. Again, this is going to add to a 6. This adds to a 7. The top one added to an 8. So here I go. I'm going to set up my boundary for this guy. So I'm going to go over to 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Plot my first point. Next one, next one, next one, next one. Notice I hit this guy. Now it's going to start coming back up. This is where that V shape starts showing up in here. And I can continue my boundary because it's moving at this pattern. It's like two lines that are working together here. This one goes that way. Solid line because it's equal to, and I got that guy all taken care of. The next one, well, we're going to have to do a little bit of tweaking here too. I'm going to add x to both sides. I want to start getting y by itself. I'm going to graph this guy. I'm going to actually write it like it's an equation. So it's going to be 4 plus x. And then I'm going to divide everything by 4 to get y by itself. So I can graph this boundary line just like any other equation that we've worked with in previous chapters or anything of the like. That's going to become a 1/4 x. I know I'm changing the order in which I'm writing things. Hopefully you're going to be okay with that, because x divided by 4 gives me 1/4 x, and 4 divided by 4 gives me the number 1. So I have y equals 1/4 x plus 1. Don't worry about the inequality sign here. It's just a boundary. When we test a point, we're going to use the original guy up here. My arrows are really having problems today too. Sorry about that. So I'm going to graph my point. I'm going to start at my y-intercept of 0, 1. And my slope of 1/4 means I'm going to go up 1 over 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Now, do not make the common mistake that people get into when they are graphing an absolute value and then they switch over to something else, is that then all of a sudden everything becomes a V. One's a line, one's an absolute value. So one's a line, one's an absolute value. If it doesn't have the bars in it, which means absolute value, it's not making a V. If it has the bars, it's making the V. Just remember that. So I've got these two guys. Both of them have the equal to part in their inequality. So both of them are solid lines. Now we're going to take a look at our shading. Looking at our shading for the green guy, since we just finished with that, I'm going to plug 0 in because I can use 0, 0 since it didn't go through that point. Hooray for us, making things a little bit easier. Overwrote that a little bit. I've got 0, 0. I'm going to have 0 plus 0 is greater than or equal to 4, which means that 0 is greater than or equal to 4. Bad news bears, we just tested the point 0, 0 for the green line. It did not work, so I will shade on the other side of the boundary. And here I go, shading, 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 lots and lots of shading, lots and lots of shading. So here I go, still shading, being complete, being thorough, getting all my shading in there. I'll throw a couple extra ones in there. I got my shading down. Blue guy is next. Here we go. Again, I'm going to test the point 0, 0. I'm going to use that test point 0, 0. It's easy to work with. I'm going to go with it. 0 is less than or equal to the absolute value of 0 plus 4. That means that 0 is less than or equal to the absolute value of 0. That's 0. Hooray for easy to work with numbers. And I'm going to add 4 to it so I get the number 4. That's true. That test point worked for the blue one, worked for the absolute value V. So I'm going to shade down. So here we go. Shading down from my V, down from the V, down from the V. Start at the V, work down. Again, we've got an area where you've got blue and green overlapping. And I'll highlight that stuff out this time with some stars. Goes around like here. We've got it over here. It comes along the line, all that good stuff. All of this stuff in here, that's our solution region. I'm highlighting it out so that you can see it really easily. That's all there is to it. So there you go, three different examples. Each took about 5 minutes to really talk all the way through of graphing inequalities. Hope this helped for you. Remember, just like I did, use a test point, show your work. You'll work out just fine if you do that every single time.